I think he's sworn off those.
Yeah.
Oh no, it was very clear.
All right, here, look for it.
I see it.
Okay, I see record beeping.
Gentlemen, I think we're recording. This could be live on a Monday morning, or it could be replayed in the archives of Santa Barbara's astronomical unit. Hello, everybody. I'm Baron Ron Heron, proud to be not only the host, but the vice president for a few years of Santa Barbara, California's only astronomy club, except for the kids. We'll hear about that on the night of the 4th of February coming up when we have an online meeting of some kind. Ladies and gentlemen, it is Monday morning, the 24th of January, 2022, and this is the 49th edition of the SBAU Astro Hour. This hour, we're going to talk about the Artemis program from NASA, replacing Apollo, which last time went to the moon back in the 70s, almost 50 years ago, Apollo 17. And we're also going to take you out to Orion, to the star Capella, visit an asteroid, asteroid 7 Iris, talk more about the Hertzsprung-Russell diagram. But before we do anything else, let's meet the rest of the board and welcome, oh, there's the man finally joining us at the bottom of my screen anyway, Bruce Murdoch, whose wife is, how you doing, Bruce? He's a longtime member. Well, he'll clock in.
He's muted. He's muted.
Yeah. President Jerry Wilson.
He's making a lot of noise right now, so I muted him.
That's right.
Good morning.
How you doing, everybody? It's Jerry Wilson, president, 4 years. Wife is Pat Forgy. And he also writes, I guess, incredible columns for our newsletter that comes out for the club every month. That would be published by Tom Whittemore, the man at the bottom and left of my screen. Tom's a former Westmont College science instructor, now a regular baker of sourdough bread, and he's married to Maureen. And we're still getting Bruce tuned in. Here's Chuck McPartland, our outreach coordinator, trying real hard to outreach coordinate. Not doing well, are we, these days? There must be something going on. I've been out of town. Is something happening worldwide that I should know about? And Tom Totten, our webmaster, technical wizard, and former president. He's married to Suzanne, an artiste. Chuck is married to our merchandise manager, the lovely Pat. And Bruce is married to Bonnie. And Tom Whittemore is married to Maureen. I said that all right. Tim Crawford's birthday. He's listening probably. When was his birthday?
It was Saturday, the 22nd.
Yeah, he
Happy
turned
birthday,
20,
Tim.
Happy
Yeah.
birthday.
turned 29 again.
A lot of candles.
I guess if you're watching this on YouTube, ladies and gentlemen, you can comment, right? There's a chat section at the bottom. Let's get to the cartoons first. If you want the silly stuff that President forwards to us, there's two jokes, two science humor, one called Halley's Comet, and the other is called The Talk. And I got off on these before we get into the hardcore stuff. Here's the Halley's Comet one, the poor side effect of teaching kids about Halley's. Young man rises in science class and asks the teacher, "How many times have you seen it, ma'am? Have you seen the comet?" "Oh, 4 times, Johnny. Sit down." What is it, every 78 years? Did I get that right?
Yeah.
76. Okay, and also from Jerry's secret source, some incredible website, we go to one called The Talk. Get this. What is that?
Is that the Pleiades over there to the right?
It's
We'll figure that out later.
Yeah, there's 2 aliens seated at the table with their
Oh, this
obvious
one, okay.
little human boy telling him, "Your mom and I think it's time we told you, son, you were abducted." Kid
That's a
didn't
really
know.
good one.
Those were strange. All right, here's looking at you, kid. Earth's moon.
That is that I forget the name of the Indian tribe. I included it in the.
I see.
Oh, did
What's
I
that?
see that? What is it?
Yakima, he said.
Yakima.
Yakima, yeah. I don't know. I couldn't identify any major asterisms or anything on that. The
Yeah.
upper left is suggestive of the Pleiades, but there's way too many stars.
Mhm.
I think this looks like the Big Dipper and the Little Dipper, maybe.
Oh yeah,
I bet you Milky Way down the middle.
yeah.
Uh,
Those are little plus signs they make on what, wood?
It's an antelope hide.
Oh, for crying out loud. It's also
Big
a heck of a-
circle.
I have a set of placemats that look just like it, but it's dirty.
Hmm.
Wow.
There's the Pleiades, 6 stars.
Yeah.
Well, that would make sense, Tom.
And maybe the V of Taurus down there.
Oh yeah,
Good one, Chuck.
yeah. Capella.
Wonder how many native tribes were into astronomy at all. Just
Oh,
this was-
probably all of them. They
Yeah.
would use that for seasonal predictions.
Not sure they all left visual records or printed records, though.
well, as
Oh,
Polaris.
hey, Chuck, here's something you taught me a long time ago at Outreach. I bet you the Pleiades is what you just described. And I bet you those 3 stars were so pointing to it as the belt of Orion and his sword is hanging down, because the belt of Orion in one way, and you taught me this at Outreach, points to the Pleiades one direction, and in the other direction points to Sirius.
Yeah.
What do you think? What do you think of that?
Could be.
Yeah, it doesn't look like maybe the sword and the belt. I don't know.
Yeah.
Yes.
Well, would you gentlemen like to phase this into talking about Star Capella and maybe Sirius, the brightest, which are all part of Orion, since that was in Jerry's talking
Yeah.
notes? Get that out of the way. Here's what I wrote down. I transcribed high overhead on Orion's foot. I didn't know Orion had a foot, along with Star
Got
Rigel.
2 of them.
All right, well, we'll see it here in a minute. Both crossing the sky's meridian. What is that, the midpoint? At
Yeah,
the
divide
same-
east from west. Yeah.
Okay, around 9 p.m., depending on whether you live east or west. Some of this I didn't understand. You're going to have to explain it. Whenever Capella, that's Italian for singing by yourself without a background music, isn't it?
No, it's a
Acapella.
little
That's
goat.
acapella.
Yeah,
Acapella,
it's,
right.
it's a
That's-
little goat.
All right, Rigel will mark true south over the neighborhood and vice versa. See, you lost me there. Orion's high in the sky, southeast, right after dark. By 9 p.m., brightest and showiest of the 88 constellations. Never, let's see here, main pattern, or let's see if I can. Yeah, the pattern is small. Others nearby include Aratinus the river, Formax the furnace, Lepus the hare, some of my favorite cartoon characters. Is that all in this diagram?
Do you mind if I interject one thing here
Sure.
for folks who like to look with their binoculars? Hey, Tom, would you mind just circling around Misa? That's the head of Orion up there, Misa. Okay, that's also known as Lambda Orionis, but it also houses Colander 69, which is a beautiful cluster of stars, nice and bright for binoculars. People really get a kick out of that. Okay. If you got a small telescope, you can get more stars, obviously, but it's a real pretty section there. That's Orion's head. Colander 69. Colander 69 is that right in there?
What is Misa? A star?
It's a
It's
star.
the head of Orion.
Yeah. Also
head.
known as Lambda Orionis. Okay.
Orion was a Greek soldier?
No.
He's a hunter.
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 Also,
Got it.
you'll notice, a bunch of the names on here, if you're a Harry Potter fan, Bellatrix and Sirius. A lot of the names in the Harry Potter books were from stars.
Okay.
How about Aratinus the river, Formax the furnace, and Lepus the hare?
Well, Fornax is way out of this picture, but Eridanus is right there on the right.
Right.
And
It's
his
a real
next-
long one, Ron. It's a real long constellation.
It starts off with a sort of like a box in the upper right.
Mhm.
That's
Okay.
the head, isn't it?
Yeah.
But are those asterisms?
No, that's a constellation.
It's a constellation. It's an awfully long one. Eridanus, or it's also called the River Po, after the river in Italy.
Yeah.
River.
Okay, Aratinus the river.
And it goes way far to the south down there. Acamar way
Yes.
down at the bottom is part of
That's
it.
Yeah. So it really swings south, Chuck, and then there's, Acamar, I think we can see here, but there's another one that's really bright we can't see. We're just, we're just
Yeah.
far up.
Okay, well, Sirius is not part of this, is it? It's outside.
Yeah,
of
Sirius is the Orion's dog following on his heels, and you can see it in the lower left down there.
Got it, right. Brightest star there is.
Yeah.
So why-
Sirius is
why-
sometimes called the dog star, Ron.
Why?
There we go. Because in
Because
your
The dog.
in
of
your
course.
your email, Jerry, the the attachment, Sirius is almost right in the middle.
Really?
Yeah, and you can now see that the belt of Orion does point to Sirius as you go down.
Yeah.
We had some guests here over the weekend, and on Saturday night it was absolutely beautifully clear here. And I pointed some of these things out that I learned from Chuck at, at outreaches. Just nice pointer.
We had a couple of spectacular nights here.
Yeah. Mm-hmm.
And way on the left is Procyon. That's part of the little dog. It means before the dog because it rises before Sirius at our latitudes.
Yeah.
And then along with that little star Gomesa, you can see that the little dog is nothing but a hot dog.
Yeah.
But one star represents a dog.
No.
Well, there's
Two
two
stars.
of them. Yeah,
Two
there's
stars. Certainly looks like a dog to me.
Yeah.
Well,
And Chuck, remember why it's called before the dog?
Because it rises earlier.
That's right. In northern climates, it rises.
really,
Mm-hmm.
the whole planet can see Orion.
Yeah, it's only
Australia.
ecliptic, so everybody gets to see it.
And
Got
hey,
it.
Chuck, I know you're a crossword puzzle nut too, like me. So what is a person who would be fearful of dogs? What would you call?
Xenophobe?
Yes, xenophobic, right? A xenophobe. Isn't that cool?
Not canophobic, as in canine.
No, they say cyno. They use the Greek root.
Greek
Oh.
instead of
Yeah,
Roman.
canis is the Latin root for dog.
Wow, that's a long word for.
Yeah, and for fear of cats, it's like ilurophobe. It's a really
Yeah,
word.
that's right.
Never had those words. Well, among other things, gentlemen, I learned about the brightest star up there. Like more than half the stars in the sky, it's a binary, and the other one is a little white. I say a little. It's a big white dwarf that's the size of the Earth, according to President's notes.
Well, that's not very big.
Well, no, but what makes it big? It's more mass. Sirius B, one of the
It's
biggest white
massive,
dwarfs,
Yeah,
packed into a sphere. They're
That
normally
mass,
not.
it would shrink more.
yeah.
yeah, right.
Huh. But it's the remains of a star that blew up to Betelgeuse size
No.
and didn't explode, or did it
No.
explode?
No,
Didn't
it's what our sun is going to do. It poofs off
Right.
its outer layers and the core collapses.
So in a globe the size of the Earth is all the stuff that was the size of Betelgeuse at one point, which would
No,
have been
some
out.
of that got poofed off.
Oh, it
Yeah.
got, but that's not a hypernova or a supernova.
No, it's more like burping.
Yep.
More like perfect.
Yeah.
Burping.
But
Well,
perfect.
Burping.
Betelgeuse actually is a very, very fluffy star. So
Uh-huh.
it's big. But Sirius, I had to go to the throat lozenge out of the room, so maybe you covered this, but Sirius is a double star.
Yeah.
And it has the Sirius B, which is known as, since Sirius is the dog star, the Sirius B is the pup. And right now it's a hard double star to split with amateur telescopes. Not because the separation isn't big, but because the Sirius A is so bright, it glares. So you have to do something fancy to get rid of Sirius A to see Sirius B in an amateur scope. You have to put a piece of black tape over the bottom of your eyepiece or twist it so that Sirius A is hidden behind that. And the diagram here shows on the right, the elliptical circuit. That's what the orbit of B looks like from Earth right now. And you see we're about where where he's got the cursor. We're about there, which is about the maximum separation. So this is the time to try and observe it and photograph it. The other less elliptical path on the left is what the orbit looks like from straight on to the orbit. That is, there's no way we can see that, but it shows the real path of B around A in the plane of the orbit.
How come one is clockwise and the other one's counterclockwise?
How do you know that?
I just look at the
Oh, good
dates.
point.
down on it. That's looking down from above versus looking from below, I think.
Yeah. So it's which side you look at it from depends on which wise it is.
Well, can we determine that because those two orbits look about the same size, one star being the size of the Earth, the other a giant star like the sun, they're both about the same mass?
No, Ron, those aren't the orbits of two stars. Those are two different views of the orbit of the white dwarf star.
Oh, just the white dwarf.
Yeah.
Right.
And it's the white spot in the middle of the screen?
No, that's Sirius.
Yeah.
that's
See
just- oh,
the A next to it?
Okay, so it is the smaller in mass. It weighs less. Or
No, it's the biggest one in mass.
Oh,
I'm talking about
Sirius is. Sirius A.
Sirius A. Is it about the size of our sun?
Sirius A is a white star, so it's like F class. So it's going to be more massive than the sun.
Yes.
Okay.
And it
Two
won't-
times the mass of the sun, it looks like here.
Yeah.
And Sirius B is 1 times the mass of the
so it's-
sun.
So it's twice the mass of the white dwarf.
But A is not going to go through what B went. It's not going to expand out, become a red giant, and
Yes, it
it
is.
will. And we'll have 2 white dwarfs someday orbiting each other.
Yeah. And
So
then
one
maybe if they
time-
spiral in, we'll get ourselves one of those type 1 supernovas.
Now, well, that sort of already happened. Sirius B has already gone through its planetary nebula stage and burped off its outer layers, a lot of which was probably absorbed by Sirius A, which gained a little bit of mass there. But A is still in the category where it's going to become a planetary at some point too.
Huh. So that burping off isn't done like a nova where you see the shell for years.
And that brings us to another plot we have up here under the Hertzsprung-Russell diagram.
Aha.
It shows how mass determines the end fate of the star.
Okay, we had this diagram last week and Tom is busy.
No,
calling it
this
up.
is a different one.
Yeah,
Oh, it is?
Jerry's really filled in a lot of blanks with the latest email. Yeah.
Tom, can you find that illustration?
Is
Mass.
this the one? Is this the one you wanted?
Yeah.
Ah,
See now on the left, the axis goes up for mass. At the top of the left side, things are more massive. The protostars more massive. At the bottom, protostars are less massive. And then this shows the life cycle that each things of this mass is going to experience based on its mass. Mass determines the life cycle of everything. So a real lightweight protostar becomes a brown dwarf, and that's it forever.
Yeah.
The protostar here for a red dwarf, it blows up and becomes a white dwarf. Our sun is a yellow dwarf, and the protostar is intermediate weight. It becomes a red giant, then it'll become a planetary nebula, and then it will become a white dwarf. A white dwarf has no heat source. It just has leftover heat. It's coasting. It's just cooling off forever.
Yeah, from a very high temperature, like 30 million degrees centigrade.
Right. So a blue supergiant is the initial stage of an intermediate mass star. It becomes a red giant, and it becomes a supernova with a neutron star, and it becomes a neutron star core left over. It can also go through a blue supergiant stage.
Jupiter isn't quite warm enough to be a brown dwarf, correct?
That's correct.
Yeah,
Not massive enough.
but Jupiter does have its own. Go ahead.
I think it's like 13 or 17 Jupiters to become a brown dwarf.
Yeah. So Jupiter does have its own heat source inside from
So
gravitation.
does the Earth.
Yeah, so gravitational contraction and radioactive elements. Back in the 1800s, I think it was Maxwell or Helmholtz tried to figure out the age of the Earth based on the fact that he assumed it was a molten lava sphere at one point, and then he did a calculation in classical physics of how long it took for that heat to dissipate into space, and therefore for the Earth to completely solidify through and through. And he came up with a fairly short period of time. Still a long time, but much shorter than the real value is. But in that time, he did not, and nobody knew that there were radioactive elements in the Earth, and they are a source of heat. So he figured it out as all coasting heat from the molten Earth. But now we know that there is a heat source in the Earth with our radioactive elements that add, and when you take that into account, you get the right age for the projected age for the Earth turning solid.
But in the remnants of a star like a neutron star or a white dwarf, there's no fusion going on.
That's correct.
And yet
That's right.
So there's not, what counteracts all that weight? Why doesn't it just slip down into a black hole and collapse on it?
Excellent question.
It's degeneracy pressure.
Yeah.
Right.
You can't squeeze some things closer together to a super amount of squeezing. For example, with a white dwarf, you're trying to squeeze all these electrons into the same ground state, and their fermions, they won't go. It takes a lot more pressure to press them together. In a neutron star, you're trying to squeeze all the electrons have been pushed into the protons and become neutrons, but now you have trouble squeezing all these neutrons together. So there's a resistive force for that.
Right.
With more mass than for a neutron star, there's no known mechanism of resisting the crush. So people jump, I think, incorrectly to the assumption that it's going to become a singularity. My feeling is that there's other things that will resist crushing that are much stronger. But that remains to be seen. The two top ones, blue supergiants, can become directly a black hole with collapse, or it can become a supernova and become a black hole.
Right. This is a great diagram, Jerry. And, you know, Ron, you have to remember that these end stages for all of these things, okay, basically was a core. It used to be a core of a star. It's going to mention in the case of the white dwarf, and this is just rough, the temperature of that used to be a core, right? It's about 100,000 kelvins, okay? So it glows in a different part of the spectrum, the ultraviolet, okay? And like Jerry said, you can't push electrons together anymore. So that's what you got in a white dwarf.
Well,
Tom, you said 100,000 Kelvin. Isn't it like 100 million Kelvin?
No, it's about 100,000. And if you work out from that temperature, the kind of radiation that'd be prominent, it would be in the ultraviolet somewhere. Okay.
is
The number
Kelvin
you quoted, Tom says, is that's the core temperature to initiate hydrogen fusion.
Right. Thanks, Jerry. Yep. Mm-hmm. You know, the internal temperature of our sun is roughly 13 million kelvins, and it's hot enough to engage, you know, hydrogen going into helium.
Yeah, 10 million, not 100 million. No.
Yeah, so something like that. Mm-hmm.
Now, a neutron star can do another supernova if it's in a binary star and it's bleeding material off of a companion. Enough of it can build up on the surface until it initiates a thermonuclear reaction, and then it blows up again.
Same thing with a white
That
dwarf.
repeats, or that
Yeah,
can repeat.
same thing with a white dwarf. Yeah.
Right. Thanks, Chuck.
Does anyone know what's the shortest time period to create a white dwarf from a star? I'm just thinking that in the initial, after the Big Bang, what would be the shortest time period to create a white dwarf? And would that white dwarf, as it cooled, could it become another star by drawing in more material, or it would just go to supernova, drawing in more material?
Right. It would go to supernova.
Mm-hmm.
But eventually, if you just have it all by itself and it's not sucking in material, it'll become what's called a black dwarf, which will just be a ball of carbon and oxygen.
Yeah. A cinder.
And the other thing I wanted to mention.
I thought neutron stars only lasted like 10 million years. Like, isn't Sirius going to become a neutron star?
No.
I don't think so. It's not massive enough.
But
White
its
dwarf.
life is very hot and it's going to be very short. I thought it was like 10 million years.
Yes.
are those
Well,
the-
it's only 2 solar masses, so it's going to last,
Okay.
Mhm.
hundreds of millions.
Yeah.
what are the
there's
ones?
There's some sort of formula that shows that the more massive a star, the shorter its lifespan. And I'm really impressed, like some stars, if they're really massive, they may only last, I think 10 million might be the shortest, maybe shorter than that.
Yeah, and they last longer now than they might have in the past, because when you have heavier elements to pollute the atmospheres of the stars, they resist collapse a little bit better. And so you don't get as many of the direct to black hole collapses as you used to. That's like a 60, more than 60 solar masses type event.
Does science know what I guess we just can conjecture what the heck happens to all the protons, neutrons, electrons that get squished into a black hole. They just all occupy the same space, don't they?
Called a singularity.
Yeah,
You can't know because you can't get information out of it.
yeah, okay. Well, what are the little spinners that have streaming north and south, and they're whipping around? in
Neutron
space?
stars, pulsars.
Mhm.
Oh, they're pulsars, but are they also neutron stars? that are
Yes.
just
Yes,
spinning up?
yes. Big magnetic fields, Ron.
Pretty much all stars are spinning like our sun is spinning, isn't it? Our 22-day
Well-
cycle or
Rotating.
rotating?
Yeah, they have different
spinning's
rates.
okay, Jerry. Spinning's okay. Some of these stars are spinning like 30 times a second, just, just rough,
Maybe even 1,000 times a second. But
Yes.
I think
yes.
they just recently found a neutron star. I think it was in one of the Magellan clouds that it took like 13 minutes to rotate. So they're looking into that. Why would it be so
Wow.
slow?
That's slow. Yeah,
Must
that's
be interacting with something, a magnetic field somewhere.
Yeah, it's giving up energy somewhere.
Yeah.
The star Vega is a fast rotator. It's what is it? It's an oblate spheroid.
I think
Yeah.
you're thinking of Rigel there, or Regulus.
I thought it
yeah,
was Vega.
Altair.
It's
Altair.
rotating so fast.
Oh, Altair. That's right. Altair is
It's
Regulus.
Okay.
awfully fast. Yeah. 10 hours, I think, Chuck.
Yeah.
Huh. But they don't get the streamers until they shrink down, right? A star doesn't throw a streamer north or south, or black holes do.
Well,
no?
our sun did that when it was forming.
Did it?
I mean, it probably had jets. You see what are called T Tauri stars
Mhm.
that are young that have jets like that. So our sun may have had that in the past, but you have to have an accretion disk, I think, to start getting that. At least if there's mass coming out. Now with a neutron star, that's a whole different story because you've got all the strong magnetic fields.
Yes. Yeah.
Okay. Well,
Well,
let's move on. Let's move on to Artemis. If that's okay with you.
Okay.
all right, let's do Artemis. Well, if we have time later, we'll talk about asteroid 7 and see if Chuck McPartland's been doing any occultation. What's the story from NASA, Mr. President? You want to tell us?
Well, this is Artemis is our return to the moon and partially our return to Mars. Everything we're planning to do to get to and be on Mars, we must first do on the moon. And the Artemis is designed to do that, not only just put boots on the moon, but to develop the infrastructure and debug it. The Artemis is going to fly the Orion capsule, which has the upper stage of the entire rocket ship is a crew module, the Orion, a service module with life support and a rocket engine and a launch abort system. It'll be launched using NASA's Space Launch System, which is the largest rocket ever. Below the upper stage, it has the cargo hold, exploration upper stage, core stage with 4 liquid fueled engines and 2 extended rocket boosters. 2 minutes after launch, the solid rocket and the abort system are jettisoned. 8 minutes after launch, the core stage is depleted and jettisoned, and the upper stage fires briefly, putting the payload into a parking orbit around the Earth. After they decide that's good enough, I think my diagrams are a little simpler and more easy to read. Could you shift to those, Tom?
Or just the simple ones?
Yeah. They illustrate one point at a time. You don't have to explore the thing visually.
I see a cat.
Yeah.
Okay. So in the parking orbit, NASA decides everything's good, and they will fire the exploration stage to put the payload on a trajectory to lunar orbit. Once on their several-day coasting trip to the moon, the exploration stage is jettisoned. Now, the key difference between Apollo and Artemis is that this mission, the Artemis mission, will arrive to a pre-staged infrastructure. Everything that goes to the moon is not in the Artemis. It's already waiting there. So everything, and that includes what will be set up on the moon by commercial vendors, will be living modules, rovers, power stations, And there will be a mini space station named Gateway around, like the ISS, around the moon. It'll be built up of modules, and the lunar lander will be that goes from Gateway to the surface, is being built by a contract from SpaceX and will already be docked at the Gateway, which is shown here as the kind of golden thing with the two solar wings on it. Gateway is an expandable system and will be used supporting multiple missions as other modules are added for spacecraft coming and going from the moon. Gateway is in a highly elliptical orbit around the moon called a halo, and is maneuverable so that it can overfly any part of the moon. The next picture shows the Artemis, the Apollo capsule, and its life support module about to intercept the halo orbit in the region of the moon. This shows the highly elliptical halo orbit. The lunar lander has three goals: to send from the halo orbit to the lunar orbit. And remember, the lunar lander is already waiting there at the Gateway. It'll descend to the lunar surface, and it will ascend back to the orbiting Gateway when everything's over with. The crew and service module leaves Gateway and heads back on its multiple-day journey to the Earth. The Orion capsule will now shed everything else it has, and it will enter the Earth's atmosphere at 25,000 miles an hour. Air friction will slow Orion to 200 miles per hour, heating its leading edge to 5,000 degrees. 3 parachutes will slow Orion to 20 miles per hour for a cool dip in the ocean. I also sent an email that showed the dates for this. The first launch of the Artemis with the Orion capsule, unmanned, will be in 2022. And the first manned mission to actually land on the moon will be launched in 2024. A very ambitious schedule.
Why the halo?
Why that orbit?
Yeah, why the halo orbit? Why not just go around the moon like we did in Apollo?
Well, they want to have services at the moon so that you don't have to. There's so many thoughts in my head. I'm having trouble putting them in linear order, but it's a more versatile and a safer system. Let's put it that way.
Yeah, plus you want to be able to orbit any part of the moon, so they can easily adjust this orbit to go over any part of the moon.
They couldn't, just by going around it like a space station does the Earth?
Well, this is going around it. It's just not a circular orbit. It's an elliptical orbit.
It looks like the Juno orbit around Jupiter.
Yeah, kind of. That's an elliptical orbit.
It's kind of exaggerated a little bit here.
Yeah. This is not the scale.
What is the period of the orbit?
Don't know.
Okay, so they're going to build an international space station called Gateway that goes around, and that's what's waiting in the moon. Why not plan to have something down on the surface and then land and go get into the damn thing?
They will, but they're going to have rovers on the moon already waiting to be used. Okay. It will have living quarters on the moon waiting to be occupied. It'll have power sources, nuclear power sources, and solar on the surface of the moon. And what was the other thing that it had?
They're going to put little factories basically to make to mine metal and oxygen and water and stuff too.
Right.
Didn't Elon Musk's SpaceX make the Orion capsule already?
No, Lockheed makes that. They're having a little bit of trouble with it. It's delayed, but Elon is making the lunar lander that goes from Gateway to the surface of the moon.
But SpaceX isn't making that monster space rocket, though, are they?
No, they're not. They have their own version, but it's not quite as big.
That sucker is longer than a football field.
Yeah.
Can you imagine?
It's taller than the Saturn V, and it produces almost half again as much thrust.
Wow.
Elon's Starship will do similar things, but it's not going to be ready on this time frame.
Well,
on the moon, they're going to have rovers, right? You said.
Yes.
Are these to support people, or are they like the ones we have now? They're just instruments.
No, they're like the moon buggies that the Apollo had.
Okay.
So
there are designs out there for ones that are more like buses, which have a pressurized module and everything.
Well, that was the MOLAB. That would be one of the designs that predated the lunar rover.
Well, I
There's
hope
a
we're
big
all
tank
along.
on, there's a
I
big
hope we're
tank
all-
with 4 wheels and then another 2 wheels out in front on a springy frame.
They had some neat craft in 2001 Space Odyssey, didn't they? I wonder if they're going to go looking for that big slab buried on the moon. Here,
Yeah,
here's-
the monolith, huh?
Monolith in the movie 2001 was buried in Clavius.
oh,
Okay.
is that the biggest Mare?
No.
No,
No,
it's
it's a big
a big
crater. Big crater. It's a
Oh, it's a
beauty.
crater.
Yeah.
Well,
Yeah.
here's the part of your notes that I liked very much. The 2 reasons for going there. Number 1 is to get ready for Mars. Mars will be later, and everything we do on Mars will have been tested and done on the moon.
Yes.
Similar, except no atmosphere on the moon, but not much on Mars either.
Yeah.
Deep space Orion capsule. So we got 2 years. We'll probably stay through this alive, gentlemen, won't we? 4 astronauts.
Just
One,
a little thing about Clavius is it's a big crater, and usually first quarter moon we show it to the public, at outreach. It's really beautiful.
well, maybe when the Russians wonder why we're shutting down, we can tell them there's a pandemic, and we'll be truthful because we do have a damn. Remember that, Dr. Floyd,
Yeah, they had a pandemic in the background.
and yeah, pandemic on the moon or something.
Mm.
Wow, interesting stuff. Mission to Mars.
Yeah.
Well, we'll be watching, I guess. God, did they test a rocket that size? Did that get tested?
Oh, yeah, it's been tested. It hasn't flown yet, but it's been laid on its side and the engine's fired. And it's been pressurized and overpressurized, so it'll take it. And they just had a problem with the steering mechanism, I think, on the rocket engines, and they fixed that. And so they're ready to go. It's in the, what is it, the vertical assembly building. That was a cool picture you had of the rovers there, Tom. Let's go back to that.
Come on. Please wait.
Remember what the
Yeah.
Apollo guys?
See,
Ron-
there's 2 kinds of rovers there.
Yeah.
And
Ron,
I don't know what type they're gonna have, but they probably could have both of them. It's pretty cool.
Ron, I swear to God, I see Elvis Presley in there.
The Apollo guys.
This is
had
a real
golf cart.
throwback in time. Go
Yeah.
Google MOLAB, MOLAB, and get down to the Smithsonian part. You'll see a picture of what we developed back in the 60s here in Goleta.
Huh.
Well, that looks
And
like
it
you could,
looks a lot like that thing they have there.
in the background, in the middle there, you could take your spacesuit off, and it's you could breathe inside just like a capsule.
Yes.
Because that little sucker they drove on the moon in Apollo 17 or 16 wasn't much to it. The little car,
Yeah, it was like the one on the right there, a dune buggy.
Oh, yep, there it is. I see it. But this is what it's
What-
going to look like someday.
So on the moon, would your lithium ion battery pack, could it catch on fire?
Ooh, what are you
It should,
asking?
because it's got oxidizer in with the lithium.
It could, not should. It shouldn't, but it's capable.
You hope not.
You know, the element lithium gets no respect. It's number 3, but you never hear about it. It jumps from hydrogen to helium all the way to carbon, right past lithium, and yet
Right.
it's in the batteries, and it's all over some deserts in northern Chile. It's lying right there on the ground. Look at this. Is this what it's going to look like eventually? Is that Clavius? No. Where are we going? Does anybody know? First time.
I don't know the projected landing spots.
The
Well,
best
probably-
place that they're thinking about for a base is, of course, on the South Pole, the
Yeah.
Aitken Basin. That's where everybody wants to go.
Yeah.
Yeah. And as far as
The original lunar rover used nickel silver batteries, which are rechargeable, and I guess they'll be using rechargeable lithium batteries now.
and they're still up there, aren't they, on the moon?
Oh yeah, oh yeah.
Oh, bunch of stuff we
Go
left.
over and put a charger on the batteries, and you can probably drive them.
Is it safe to assume that China is pretty much staking their moon landings on the far side that we don't see? Or are they going to be on our side as well?
They're using robots.
Oh, they're
so
not
far.
landing. Okay.
I don't know the plan for manned landings by China.
But the pictures we've seen of the far side of the moon, it's a pretty rotten place. There's nothing but craters around there. There's not as many seas, if you will, or mares. Wow, look at that.
No, it's got a very
1963.
tall 6,000 meter bulge and on the top part and a big 6,000 meter depression down in the bottom part.
The Oscar Mayer Wienermobile.
Oh yeah, that's it. You found it. Okay.
It's been straightened out.
Exactly.
Molab.
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 That's cool. But Elon Musk is definitely in there, right? He's going to do part of the gateway. Is that what you said?
Yeah, Elon Musk is building the shuttle from the lunar lander that travels from the gateway to the surface and back up.
Okay. We sent 3 Apollo at a time, but one of them had to stay in orbit and didn't get to land down. They were all very good about it. I guess it'll be the same thing with this. So somebody will remain up in the station, and the rest.
Well, the person that was left in orbit around the moon got to see the far side and got some spectacular photographs.
Yeah.
Yeah, they were all good about it, but I imagine
Michael Collins, right?
Michael Collins. That's right.
and 11, right? But 4 guys are going.
Wasn't he
4
calling
guys.
himself like the loneliest guy?
Yeah.
This guy.
Wow. Then there was Apollo 13, and then we got him back. We all remember. We don't have any
Yeah,
Apollo
Houston,
13.
we have a problem.
Yeah, we sure do. We saw the movie, didn't we?
Yeah.
Fascinating stuff. Deep space Orion capsule. If mankind doesn't end it, we'll get there, I guess, on the way to Mars. I wouldn't go to Mars. I don't know. Would you guys, if you were younger and had the chance?
Yeah, if they had a 5-star restaurant there, I'd go.
They got McDonald's, I'm pretty sure. Artemis. I love
You
it.
know, you might end up with cancer by the time you get there because of the radiation you're going to be exposed to.
I heard you could solve that with water in the hull. Water.
You can lower the risk with water, a layer of water surrounding the capsule.
And you got to put the water somewhere anyway. I got to drink.
Yeah.
Fascinating stuff.
They have those things on the ISS. They have a safe room in case if they see a solar flare, the astronauts will go into one room that has extra thick walls.
Well, it's still like the Old West as far as the different countries on the Earth. Are we letting each other know? United Arab Emirates, what if they decided they were going to land on the moon? I mean, they're on Mars.
They're welcome to do it.
Well, except that sooner or later we're going to clash. We should combine forces.
That would be
There you
nice,
go.
but people don't act that way.
No, we sure don't. And where did you get this, Tom? Is that part of, I don't recall seeing this in Jerry's talking notes.
No, I didn't send that.
Okay.
Tom found this
Actually,
on his own.
Yeah, the website is called Insights on India, and somehow they had the copy of this Artemis mission JPEG. But it's a NASA JPEG.
This is Artemis 1. It's the unmanned visit testing of the equipment on the way. And Gateway, I don't think is involved in this.
Well,
You're right.
This will be this year, won't it?
No, 2022 is when they're going to launch
We're in 2022.
We're in 2020, yeah.
Yeah.
How time flies.
When you're having fun. Fascinating. Well, that's great. We'll keep everybody posted. I guess we got about 20 minutes almost. Anybody got an update on that incredible telescope? Since that's what our club's all about. We got the most awesome James Webb that's arrived, L2.
It's just
It
arriving
seems to be
now.
doing everything it's supposed to.
Yeah.
They
All the
have a
single
way
point
of-
failures haven't failed yet.
Look at that. It says complete. They're in L2 orbit.
Mhm.
Wow. Okay, and that's out far from the Earth, away from the sun.
Mhm.
And it's going to take months to somehow they can figure out with radio waves how to position those 18 hexagon shaped kill. There's a Black Panther about to eat our outreach coordinator right now.
No, they do it by looking at a distance. Well, I mean, all stars are distant. They look at that and they have algorithms that tweak the mirrors so that when the sensor in the telescope receives them, they see that star as a point, not a blur.
Oh,
And that can be done in an automated fashion, although they're probably going to have people in the loop on this one.
Okay. And we're looking at 6 months before we start getting anything back, assuming everything is in place.
That's when it's ready to do science. You might get some of their early images before that.
Yeah.
Is the primary mission the distant galaxies, 13, 14 billion light years
Even the
away?
first stars.
Right. So Rhonda, it'll look back when the universe is about 400 million years old. That's amazing.
400,000, isn't it?
Well, I thought it was 400 million.
Oh, okay. No, I'm thinking CMB. Sorry.
Okay. Yeah. Yeah.
But you can't see stars that far away. You can see the galaxies that have the stars, but the stars would be really too small. They're just a blur, right?
Well, we'll find out what came first, stars or galaxies, huh?
Back then they
This
weren't
could
spiral.
This could do it.
And then it'll concentrate on maybe figuring out how to see exoplanets without the glare of
Yeah,
it.
that's definitely part of the mission, I know. Yeah.
And to get atmospheres of exoplanets with spectroscopy.
Yeah.
Why are there several layers on that tennis court sized sun shield? Why not just one layer? Does anybody know?
2 layers are better than 1, and what, 5 layers are better than 1?
Yeah.
Okay, but if it ran into even a speck, it would go through all 6 layers, wouldn't it?
Well,
that's
that's
right.
why they've over-designed it.
Uh,
But see, those Mylar sheets are actually Kevlar sheets, metallized, are not flat. They're intentionally designed so that light that comes into the middle, or heat for this matter, gets bounced around toward the outside. It ultimately gets rejected. It doesn't stay there.
but
That makes sense?
Yeah.
I
So
heard
each layer of that has the ability to push the heat out, bounce, gone to space.
wow.
I just want to let you know that Jerry got his electricity got cut off at his house. He gave me a call, so he might not be
Oh.
coming back unless they get it restored. They must be working in the backyard there.
Oh, we lost the president.
Sounds like it might have been an oops.
Yeah, we don't have high winds. Well, Edison does that. They've done that in my neighborhood. They say, we're going to go turn off the power, and they give you notice, and then they do it. They've been
Yeah.
replacing power poles here.
Well, Jerry's having work done in his yard and
Right.
around, so that's probably what
Oh.
that is.
Yeah.
Maybe he'll come back. We got 15 minutes, give or take. So it's exactly 1,000,000 miles. 1,000,002 would not be a Lagrange point. 900,000 wouldn't be a Lagrange point. It just happened to be 1,000,000.
Well,
No,
there it is,
look at
907,000.
I'm sorry, Chuck, what did you say first?
It's 907,530.5 miles. You can see it on this diagram here.
Oh, okay. Well,
Oh.
all I've heard is 1,000,000.
Well,
Bruce?
they're going to round it off. They're not going to read off
I-
a string of numbers
sure.
like that.
And what was your comment, Bruce?
Basically the same thing.
Oh, okay. So it's going to be going around and around, orbiting a spot. Why couldn't it just stay stationary without orbiting in the spot?
Because it's not a perfectly stable spot, so they'd have to drive it anyway. And putting it in an orbit like this it's easier to keep it stable.
Well, there's 4 or 5 Lagrange points. There's one on the other.
5,
There's 5.
What if it
2 of
were,
which are stable.
okay, is this,
Actually, 3 of which are stable, right?
what does that mean? What's an unstable Lagrange point? Is
Well,
that-
if
Well,
you put
like-
something there, it tends to leave it.
oh, so the
The
10 o'clock
Lagrange
two-
point, I think it's called L1, that's between the Earth and the Sun.
Right.
You get a balance of the gravitational forces, but if it gets a little closer to the Earth, then the Earth's gravitational force prevails and it gets sucked into the Earth. If it gets a little bit closer to the Sun, the reverse happens and it gets sucked into the Sun.
Okay, look at this.
That's L1. L5, L4 and 5 are stable, as is L2.
Well, L2 is kind of marginally stable.
Mhm.
Okay. but
Right,
it's gonna-
right.
But they're gonna have to monitor this thing all the time. Those rockets are gonna be firing constantly, aren't they?
No, they aren't. If you put it in an orbit like this, it will tend to stay stable.
Well, Tom showed a moving diagram at one point that looked like the orbit was shaped like a peanut. It came in and looped out, and kind of like a sand, glass, hourglass shape?
No, it's not going to be like that. Here's a view of it.
Okay, that's not the moving one that I'm talking about, but that's
Well,
all right.
if you take this orbit and now you move it around the sun, that's the diagram you're probably thinking of. This is as though you're following the Earth around the sun and the L2 point. And so it looks like it's a single figure like this. But if you're also orbiting the sun, it'll stretch this out into a big helix. And that's probably the diagram you saw.
Okay. The sun goes through the 12, actually 13 counting Ophiuchus zodiac signs, right? And if the sun is ever in a sign, what's it in right now? Capricorn?
Yeah.
Maybe, yeah, Capricorn going towards Aquarius, I believe.
All right, that would be the one area of the sky that James Webb would not point at, would it?
Right.
Everything
Right.
else is fair game? Preferably.
Not everything else. There's a big region around the Earth and the sun you wouldn't look at that point.
Yeah.
But it's going to orbit. So, as it goes around, it gets to see the whole sky.
Mhm.
Okay.
There's other constellations the sun goes through too. It goes through Cetus a little bit, So it's not just 13 really, but
Mhm.
Oh, well, I was.
You just have to wait a full year to see the whole sky.
yeah.
Can you lower that picture or, well, you changed that on us, Tom. I was
Sorry,
trying to
which one?
The one you just had on before this. Because the last one that had,
The fifth one in that's got the sun. There you go.
oh, yeah. L4 and L5.
Mhm.
Can you say in a couple of sentences why something locks in there and doesn't move anywhere?
Because the gravitational forces balance
Right.
They
between
do.
the Earth and the sun.
Huh.
You got the same thing. That's where the Trojan asteroids are around Jupiter.
Right.
They're in the L4 and L5 points.
Right.
Oh,
So Ron, that angle there between L4 and L5 is 120 degrees.
it is on
Yeah.
the left side of the circle.
Yeah, you see those two lines. One connects L4, one connects L5. So
Okay.
those things are 120 degrees apart. Okay. And like Chuck mentioned, that's where you see the Trojan asteroids too. Okay. Stable points. Those are caused by Jupiter though. Okay.
Yeah. Those
That's
are in
Jupiter.
Jupiter's orbit. Now,
Right.
these would be where we would have Trojan asteroids.
Correct. That's right.
Well, now, do you suppose someday?
I was telling the guys before that, we calculate these at Westmont, my Astro class, and it's a serious calculation,
What can you tell us, Chuck, about Mr. Lagrange? Who was he? When did he live?
He's a mathematician in the 1700s.
1700s. Mhm.
He came up with that long ago?
Yeah. Well, once you had Newtonian gravitation, you could figure these things out.
Right.
Huh.
Nonlinear equations, but you can deal with those.
There's
a lot of pencil and paper.
Yeah. So when you do in physics, you do the central force problem. Okay. You end up, if you take certain root with what's called the Lagrangian. Okay. And you perform, it's an equation. Okay. And you perform operations on the Lagrangian and you basically get Newton's laws. It's just really beautiful stuff. So it's one of my favorite parts. I love mechanics in physics. And it's one of my favorite parts when I was studying this stuff at Purdue.
Well, wasn't part of Newton's stuff thrown out with Einstein's theory?
Only with very large masses and
Right.
very, very high speeds.
Yeah. So Ron, just briefly, the beauty of this stuff is you don't have to resort to force. You basically do operations on something called the Lagrangian. Okay, basically derivatives and time derivatives and things like that. And you get Newton's equations. It's just gorgeous stuff. Okay. And you don't even talk about force, Ron. Okay. You're talking about energy and performing operations on energy. And you get orbits. You get what things do when they're involved in gravitational lock. Okay. I know that sounds really fuzzy and everything, but it's really pretty stuff.
Well, this much I pretty well know. There's an innate sense that the further out you go, the more you're going to trail the inner orbits. Does that make sense? Obviously, Mars doesn't keep up with us. It's going a little slower, but it's further out, right?
And that's why you want this L2 point. And that's what Jerry explained in his subsequent email, is that you get a little bit of extra gravitation here. So you have to move faster. And so you end up keeping up with the Earth.
And so that point, that gravitational, whatever you want to, concentration is what moves the James Webb, or is it rockets that are always moving it faster and heavier?
No, it's not rockets. It's that Lagrange point, the gravitational forces there.
And Tom, if you could get that picture you just had, I'll just say something to Ron for a second.
Which one? Was it
You
Jupiter?
just
or what?
had it. It was like a head-on view. That's good enough. So Ron, you see the Earth there, the ball, okay, and the moon and everything.
Right.
And then you see L2 out there.
Yep.
Now imagine the Earth going around the sun, which is right in the middle there. And it's basically taking with it L2. It drags L2 around as it goes around the sun. Okay. And this Webb telescope does a gyration around L2. So the Earth in a way is dragging L2. I know it has the help of our sun, but it drags L2 around as the Earth goes around the sun. And so in a way, it's dragging the James Webb around too, but the James Webb is actually going around and around and around this point called L2. Does that make sense?
It does, but it sounds to me like the sun's gravity has very little to do with this one, L2. It's all Earth.
No, it's a balance, so this is all a balance between the Earth and the sun. And the Earth and the sun creates these points L1 through L5.
Huh.
Okay.
Well,
Tom, let me say, so are you saying that the gravity of the sun is is equal to the gravitational pull of the Earth at this point?
Yes.
Even though the sun is 93 million miles away, its gravity is equal to the Earth at L2.
Yeah, because it's much more massive.
Correct. That's correct.
But it's 1 over r squared.
Right.
That makes it non-linear.
all right. Well, let me pose this question real quickly. If forget about James Webb, we know where L2 is. Let's say an asteroid came into our orbit, or actually was cruising along 1 million miles out from our orbit, just happened to be passing the Earth at L2. Would it be locked and stop?
No,
it'd have to slow up so much, Ron, to be, stabilized there. Okay.
but it, potentially if something happened to it, it could stay there for a while, but it's not really super stable. So eventually,
That's right. Right. Mm-hmm.
Okay, well, if it weren't, let's say it's not traveling, but it happens to be orbiting 94 million miles away from the sun, not 93, out past our orbit by one. Sooner or later, we're going to catch up to it, right?
No. It's flying in formation with us.
That sounds like the president. Is he back?
Yeah, very
good.
We missed you.
The stonecutters out back blew the circuit breaker and our modem went out.
Well,
We've got it back now, maybe temporary.
well,
I thought you did pay the electric bill.
Yeah, those pesky bills. So,
and you use it as a bathroom break.
if you want a circular orbit around the sun, you pick a place, a distance from the sun. There is only one speed at which the satellite will travel that will give you a circular orbit at that position from the sun. If you're moving too slow, you're going to fall into the sun, and if you're moving too fast, you're going to zip away from it.
right.
So the speed that the Earth has to move around the sun is a certain value. 1 million miles out, if you move the Earth out there, it would have to be moving slower to be in that orbit out there.
That's right.
So the inner orbit would eventually pass it up. But with the extra pull out there, that means that the orbit has to be maintained with a higher speed. And it's the speed that matches the Earth, even though you're 1 million miles farther out, because the Earth's gravity gives you that extra little tug, just like Chuck said.
You suppose the day will come when we're going to put something in L4 and L5, the 10 o'clock and 2 o'clock?
I think we've already got things there that we didn't put there. They're just picked up asteroids that are there. We have our own Trojans.
They're
You're
trash
kidding.
collectors.
Yeah.
we'll probably end up calling them something other than Trojans, since that's sort of associated with Jupiter. But yeah.
Yeah.
Well, I don't understand that because it seems to me those Trojan asteroids in Jupiter's orbits could be anywhere in the orbit except close to Jupiter. It would seem to me.
No.
Just no.
No.
Why wouldn't they? They're just as far out as Jerry was saying as Jupiter is, so they'd be going the same speed, wouldn't they?
Yes, but they wouldn't have the stable point. So eventually they would interact with other things and tend to get thrown out.
Huh. Well, why aren't there some asteroids in Jupiter's Lagrange point too?
There are.
There are. They're called Trojans.
Well, no, that's L4 and L5.
Oh, no, I'm sorry. That's L3 and 4 and 5.
Yeah.
I know they
Because
got
it's
stuff at
marginally
L1 on
stable.
Jupiter. They call them Hildas.
L2 is only marginally stable. So those things would tend to get tossed out of there.
Okay. And so the one on the far side of the sun, that's L1.
That's L3.
Oh, that's 3. And that's because of the sun Earth lineup. Somehow that locks it in too.
Yes, yes. Uh-huh.
At 93 million miles out, Earth's orbit, or another million miles beyond.
No,
that?
it's in toward the sun from the Earth's orbit.
Oh, it is. Well, you lost me there.
Well, look, you can see it on the diagram there, Ron.
No, everything is scrinched and nothing's to scale on these diagrams.
No, that's true. But the relative positions are there.
Wow. Well, we're following it, I guess. There'll be some news from Mars with Perseverance. Next week, maybe we'll do Iris 7, the asteroid from hell. You want to talk about occultations, Charles, in charge?
Well, did 2 last night, although they were both negatives, and they're just every couple of days there's an occultation.
They're not guaranteed, huh? You get a lot of letdown disappointments.
There's uncertainty in the positions of the asteroids and the stars. So actually, even getting a negative gives some information because the prediction was wrong.
Is this our new February? This just went away. We had the newsletter.
No. I'm actually working on it now.
Oh, okay. Well, the newsletter's coming to everybody's inbox, and we're going to have a meeting online somehow in 2 weeks, a week from this coming Friday, February 4th. And then we hope to have a general meeting with a speaker a month after that, which is exactly 4 weeks, being February 28 days. That'll be on March 4th.
Right.
Meantime,
Ron, for those of you who like to get up early in the morning, Venus is now a morning object. It's really beautiful. It's very bright. So you see it before the sun comes up in the southeast. Okay.
And it's heading toward maximum brilliance too.
Yeah, it is really bright, Chuck.
I suppose those Native Americans knew about that too, didn't they? It was the same thing, morning or night. Okay, gentlemen, take care of yourselves.
Tim and Jim there saying something.
What's going on here? Oh,
Tim and Jim have some comments.
Yeah.
Let's see what they said here.
The moon's going to have some influence on those L2 points, but not much.
Yeah.
Right.
Ah, well, they'll have, that's why it's got rockets on board, I assume.
Yep.
JWST. Fascinating stuff. Jerry, good to have you back. Good to have all of you safe.
Yeah.
You're wearing the N95 mask, if we don't have them yet. Go out and do some wheelies, leave rubber on the streets with your incredible Elon Musk Tesla cars, 2 of us anyway. And I can smell that bread, sourdough toast for your guest, Tom.
Ron, the Teslas have traction control, so they tend not to leave rubber.
Will they stop automatically if you don't? If they see something, do they have a
They will try to.
Yeah.
Most modern vehicles have traction control. My Suburban does. It's 12 years old.
What's the status on the availability? Cars, new cars, old cars, they're all short-handed, but there's plenty of Teslas, I guess, aren't there?
Well,
If you got $60,000, you can get a Tesla by July.
Yeah.
And what do you
Model Y.
plan to get, Totten?
I'm looking at the Ford Lightning pickup truck, but I'm not sure. The prices on that keeps going up and up.
No.
Hybrid. Well, we got to sign off. We've done it for an hour. Thank you. That's number 49. Next week will be 50th. And then there's 2 more weeks and we'll have a year behind us.
An anniversary.
Santa Barbara Astronomical Unit Astro Hour. Thank you and appreciate your joining us. Give our loves to your wives. Take care of yourself. Wear the N95 masks. Keep your shots coming, and we'll see you next Monday morning.